For the first video in this series, I want to talk about character encoding and what are characters as far as our operating systems are concerned. Characters are actually stored, as everything is on a computer, in digital format, ones and zeros. But every character has a number behind it. So if we look here, we're going to look at ASCII first. So ASCII stands for the American Standard Code for Information Exchange. And ASCII was an 8-bit system, meaning we had 8 bits we can work with. So 2 to the 8th power, that means there was 256 combinations that we could use to encode our characters using those 8 bits. So in the original ASCII system, well, actually, as it is now even, this first column here are the first numbers, 0 through 31. These are all codes for controlling printers. So originally, ASCII was developed from old teletype communication systems. And we used to have to you send special codes to your printers to do things like tabs and backspaces, to ring the bells, because they were based basically on typewriter technology that had electronics thrown in. So we had character returns or carriage returns, line feeds to make the line go up to the next line. So we don't use these too much anymore. We don't use these characters. Most of the things we're usually concerned about in ASCII start at 32, and 32 is the decimal code. And you can see this chart here that we're looking at. Does decimal, hexadecimal, and octal, and the HTML code, for those of you that have done HTML, for all these characters. So ASCII code 32 is a space. ASCII code 33 is an exclamation point. Then we go to double quotes, pound signs, etc. We go through a lot of punctuation. And then at 48, 49, 50, up through 57, we get the numeric digits, and we get a few more punctuations. Then at 65 is where the alphabet starts for the English alphabet. And then the English alphabet, capital letters are numbered 65 through 90. Then we have a few more characters, punctuation, and things like that. And then at 97 starts lowercase letters, A through Z at 122. So every character that's stored actually has a number behind it. Okay. One of the things you might wonder, why did they, there's a lot of technical things that go on here, but if you look, 97, which is a lowercase a, minus 65 gives you 32, which is a space. Do you think that's a coincidence? I don't think it is. So we have all these. However, we're limited. So here's 128 characters, basically. We used up some of them for controlling printers, and then we have our standard English stuff over here. 128 through 256 was used for all kinds of symbols. You can see a lot of the letters that we might use in English for certain things, but not always. Symbols with the different kinds of O's, different kinds of E's, for the words that come from foreign languages that we might need to use. They're in there. But what if we wanted another language? What if we wanted to work in another language? This really didn't have other languages. How would you do Korean or Chinese using ASCII? Well, you really couldn't. So we're limited. 128 characters for English. We could do something called a code page to swap out the second half of the ASCII codes, the second half, to do some internationalization, so that we could actually get some symbols from other languages in there. That created lots of problems, because now you had to specify that you were using ASCII, and then you had to know the codes to pull in the right code page to get the foreign symbols and things like that. So ASCII was limited because of its 8 bits. We were limited on the number of characters to 256 different things. So as a result of that, they developed something called Unicode. And Unicode is based on up to 32 bits, so 4 bytes, which 2 to the 32nd power, if you run that through the calculator, I need scientific calculator here, scientific, 2x to the y 32 equals, and I did 0, that didn't work, x to the y 32, about 4 million characters now, 4 billion characters we can use. So it's a lot more. So there was a system called UCS4 that was developed that basically always used all 32 bits, but that got to be kind of a waste because most of the time people were using English anyway, right? So they developed UTF-8. There's lots of other systems of Unicode, but UTF-8 is the one that we see a lot now. So UTF-8 is a little different in that it only uses the number of bytes that it needs. So if we're working with the English character set, where we're really only using the first 255 characters, UTF-8 actually only uses up 1 byte. But if you're using characters that come from the extended stuff all the way up to 4 million or whatever, 4 billion, it pulls in the amount it needs depending on what language. And you can see a list. So basic Latin characters, which is what we use, are 0 through 127. The controls in the Latin supplement, those extra characters we saw, are 128 through 255. Then we have extended characters here, Greek letters and Coptic letters here, Cyrillic letters here, currency symbols up here. You can see there's tons and tons and tons. There's actually geometric shapes in there. The dingbats, you've probably seen dingbats in Microsoft Office as one of your fonts. They're actually kept in here. We can have character codes for characters from any language that's out there right now. We can store with UTF-8. So there is a difference. For those of you who have done web pages, you've actually specified UTF-8 before. Most text editors store everything in UTF-8. Like something like 97% of text files are UTF-8 character sets. So that's important to know going into strings. Behind every string, there's a number. The other thing you might note about Unicode is the first 255 characters are identical to ASCII. So you can switch back and forth between those two easily if you're just using the English character set or the Latin character set.